Hi everyone, welcome back to chemistry. In this video, I want to talk a little bit more about unit conversions. So in the previous, actually a few videos back now, we introduced the idea of the metric system and putting prefixes in front of base units to either increase or decrease the size of our unit. But now I want to look at how we actually do unit conversions or use unit conversions to solve problems. So before we do that, we need to talk about equalities. So equalities use two different units to describe the same measured amount. So for instance, let's take a look at this first equality here. All right, so what I want you to do when you look at this equality is I want you to think about, all right, meters is our base unit, and is meters bigger or smaller than millimeters? Yeah, meters is the bigger unit, right? And millimeters is the smaller unit. So what I usually like to do is I like to say, all right, in one of my bigger unit, or in one of my big units, how many small units do I have? So in this case, remember we said that a millimeter is 10 to the negative third times our base unit. And that's showing us how much smaller that millimeter is. So we can multiply 10 to the negative third times our base unit, and we can convert from millimeters, from our base unit to millimeters. We can also think of this as multiplying our base unit by 1 over 1,000, right? Because millimeters are 1/1000th of a meter. Another way you could also think about this is because millimeters are smaller than meters, if we have 1 meter, if we assume we just have one of our base unit, we'd expect that there would be 1,000 of that small unit, 1,000 millimeters, in one of our bigger unit, in 1 meter. Okay, it's just like if you had 1 meter equals some number of centimeters. Well, how many centimeters? Remember, a centimeter is 1/100th of a meter. So in a meter, there should be 100 centimeters. Okay? And this makes sense. So when you think about which one's the bigger unit and which one's the smaller unit, you're always going to have a big number of little things in one of your big thing, Okay? I know this sounds kind of abstract, but we'll get into some actual calculations that'll help. And so for these equalities, right, this is an equality here as well. We're saying 1 meter equals 100 centimeters because in 1 meter there are 100 centimeters. So you can write equalities for converting between metric system and metric system, right? So a metric unit and another metric unit, right? Just like these here. Or you can use them to convert between an imperial unit and another imperial unit, or a US unit, right? Or you can use them to convert from imperial to metric. Okay, and you can have these equalities for anything. What do these equalities mean? They just set two different units equal to each other, and they're describing the same amount. It's like a dozen equals 12 of something, right? All right, so any equality can be written as fractions, and we call those fractions conversion factors because they can be used to convert between different units. So it's just conversion factors is just a fancy way of saying fractions. Okay, but you'll often hear that term conversion factor, so you need to be aware of it. All right, so what do I mean by this? So let's look at this equality here. So this equality is one we're familiar with, right? 60 minutes equals 1 hour, or 1 hour equals 60 minutes, right? In 1 hour, there are 60 minutes. So what we can do is we can split up that equality into two different conversion factors. And we can put 60 minutes on top and 1 hour on the bottom. Or we can put 1 hour on top and 60 minutes on the bottom. And the reason this is useful is going to become clear in a little bit when we start solving some problems. So we've got another equality here. 1 meter equals 100 centimeters, and the centimeters is kind of over on the left there. So I'm actually going to write it here just so that it's a little bit easier to kind of think about that equality. All right, so again, right, we can split this equality up into two separate conversion factors. Okay, and I promise it'll make sense why we do this. So you can either write 100 centimeters on top and 1 meter on the bottom of your fraction, or you can write a fraction with 1 meter on top and 100 centimeters on the bottom, right? Two conversion factors created from an equality. All right, so what this learning check is asking you to do is write some conversion factors from the equality that's given for each of the following. Okay, so for A, for example, if you have liters and milliliters, what equality can you make from that relationship? And then I want you to write your conversion factors. So remember, this is a fancy way of saying fractions. And remember, there are two that you can write from any equality. Okay, so pause the video, try this out, and come back. All right, so for A, we have a relationship between liters and milliliters, and we remember this, right? This is one of the ones that you need to memorize is liters and milliliters, or your base unit and milli, the prefix. All right, so first thing I always ask myself is which one is my bigger unit? And then I'm going to assume that I have one of my bigger unit and think about how many small units I have in my bigger unit. So in this case, are liters or milliliters larger? Yeah, liters are larger. So I'm going to assume I have 1 liter, just so I can write this equality easily. So I'm going to assume I have 1 liter. All right, so in 1 liter, how many milliliters are in there? Yeah, 1,000. 1,000. Remember, 1,000 milliliters equals 1 liter. Now, you could have written that there were 1 over 1,000 liters in 1 milliliter. But do you see why that might be more confusing? So if that works for you, if you want to write it that way, you can. But I think that's really confusing. And what this is, these are both saying the same thing, okay? They're just kind of switching the perspective. I personally like to go from the perspective of having one large thing and how many little things are in one of my big thing. But you can do it whatever way works for you. Now that I have my equality, I can write my conversion factors. And how many conversion factors should I have? 2, right? So there are 2 options because there are 2 units. 1 liter on the top and then 1,000 milliliters on the bottom, right? That's one fraction I can write, one conversion factor I can write from this equality here. The other one is the opposite, right? 1,000 milliliters can go on top and 1 liter can go on the bottom. And again, just trust me on this. Learning how to write these conversion factors will be useful later, okay? It's just not apparent quite yet because we haven't done any problems with these. All right, let's try the second one. B, meters and inches. Now, for meters and inches, I wouldn't expect you to know how many inches were in a meter off the top of your head. Anytime we're converting between the metric system and the English system, I will give you that conversion factor or that equality. You don't need to memorize it. What you do need to memorize, and what we just did ourselves, was the relationship between different metric units, right? How many milliliters are in a liter? How do I use those prefixes to increase or decrease the size of my base unit? But you don't need to know this relationship off the top of your head, okay? That we can look up or I will give you in a question. So let's look up here to this chart I have. Oh, and I forgot what we're looking at, meters versus inches. So meters and inches, meters and inches. Do we see anywhere where we have meters and inches? Yeah, I see it right here at the top. So 1 meter equals 39.4 inches. So I'm going to write that down. That's my equality. So 1 meter equals 39.4 inches. All right, so what are the 2 conversion factors we can write from that equality? Yeah, we can have a fraction where we have 1 meter on top and 39.4 inches on the bottom. Or we can have a fraction where we flip it. We have 39.4 inches on the top and 1 meter on the bottom. So we're just writing this equality in two different fractions. And there's only two options because we're only dealing with 2 units, right? Meters versus inches. Okay. All right, let's try C. And maybe draw a line here to kind of separate these. So for C, we have meters and kilometers. Now, for meters and kilometers, you do need to know the relationship between meters and kilometers. And you do, right? We learned that. So which one is bigger, kilometers or meters? Yeah, kilometers is bigger. So remember, I'm going to assume I have one of my big thing, kilometers. Now, in 1 kilometer, how many meters are there? Yeah, 1,000. 1,000 meters are in 1 kilometer. Okay, 1,000 of my little things are in one of my big thing. All right, 2 conversion factors. Okay, so one of them is 1 kilometer on top and 1,000 meters on the bottom. And then my other conversion factor is flipped, right? 1,000 meters on the top and 1 kilometer on the bottom. All right, so let's try this out with an actual problem that looks similar to something I would give you on a quiz or an exam. So a rattlesnake is 2.44 meters long. How many centimeters long is the snake? So in other words, we want to convert 2.44 meters to centimeters. So for these questions, I always start with the number I'm given. Okay, what am I given and where do I want to get to? That's a general problem solving strategy. What do I have? What information do I start with? And what is my goal? Where am I trying to get to? Okay, so I'm given 2.44 meters. So I'm going to start with that and I'm going to write that down. So I have 2.44 meters here. Okay. And that's kind of my first, I'm going to call it train track. Now, my next train track, this is where conversion factors come in, okay? This is where conversion factors come in. So what equality, right? What equality, just like we did up here, something like this, what equality can I write between meters and centimeters? How are meters and centimeters related? Which one is bigger, meters or centimeters? Yeah, meters is bigger. So remember, let's say, all right, well, I know my bigger unit is meters, so I'm going to say I have 1 meter. And how many centimeters are in 1 meter? Yeah, 100. 100 centimeters are in 1 meter. And one of the things I like to do is I like to kind of think of centimeter, like century, right? A century is 100 years. Centimeters, there are 100 centimeters in 1 base unit, right? Or 100 centiliters is in 1 liter. 100 centigrams is in 1 gram, right? Okay, so that's my equality that I can write from meters, the relationship between meters and centimeters. So what goes here? I know I'm going to have a conversion factor, okay? I know I'm going to have a conversion factor. So which conversion factor do I want? If I want to end up with centimeters, do I want centimeters on the top of my fraction or do I want it on the bottom? Because right now I'm starting with meters. And remember, this number has an imaginary 1 under it in the denominator. So this is in the numerator. So if my meters are in the numerator and I want to end up in centimeters, I'm going to want to put meters on the bottom. Okay, so using this equality, we're going to create a conversion factor, and I'm going to put 1 meter on the bottom. Why did I put meters on the bottom? Yeah, I want to cancel these units out. Yeah, let me clean this up a little bit for you guys. So I eventually want to cancel out meters. So in order to do that, I need meters. If it's in the numerator right now, I need meters in the denominator so that we can cancel those out. Because remember, if you have meters over meters, what is that equal to? Think of it this way. If you have 2 over 2, what does that equal? Yeah, 1, right? They cancel each other out. Same thing here, meters over meters. It's the same mathematical idea. This is going to equal 1. They cancel each other out, Okay, all right, so meters are in the numerator and the denominator, so they're going to cancel. Okay, and remember at the top of my at my conversion factor, I actually didn't finish it. I should have written 100 centimeters. Where did I get 100 centimeters? Yeah, from our equality that we wrote, right? All right, so 100 centimeters is up in the top, and what's nice about this is now on the top right, I'm left with centimeters. Okay, there's nothing else for centimeters to cancel out with. So whatever's in the top right of your train tracks here is going to be the unit you're left with. All right, so let's do that calculation. So that's going to be 244 centimeters. So what do I mean? How did I know to do that calculation? Well, remember, these two things in parentheses are being multiplied together, right? So when I multiply 2.44 times 100 over 1, what's 100 over 1? It's just 100. So 2.44 times 100 is going to be 244 centimeters. And that's going to be my final answer.